A focus? A directrix? A locus of points? What's that? How do they make a parabola? Well, let's see. Now remember, a focus is just a point, and a directrix is just a line that doesn't go through the focus. And the rest we'll see in the construction. So let's say our focus, f equals 0, 2, a point on the y-axis. And we're going to make our directrix y equal to -2. And then we can see that our vertex is at 0, 0. But let's label and make these things look nice. So here's our properties. We would like to see the label on that. We're going to choose teal for the focus. We'll make it nice and big so we can see it. That's the focus. The directrix, first of all, we're going to call the directrix D, and we'll have it show that. And it's going to be yellow, and we want to have it nice and thick so we can see it. So there's our focus and our directrix, and the perpendicular straight down says that halfway between is our vertex point, which is 0, 0. So we'll just say v equals 0, 0 vertex, and we'll put it down here because that will be outside of hopefully our parabola. Now, how is a parabola defined? Well, parabola says that it is all the points along here, so let's assume that this is a point in the parabola. This distance from that point to f has to be the same as this distance straight down to the directrix. Okay, so let's pick a point on the directrix. 2, -2. Okay, and all of the points to the directrix are measured by a perpendicular. So we'll go and we'll get ourselves a perpendicular through that. We're looking for the point on this perpendicular such that this distance is equal to this distance. Let's label this so we can see a little bit better what we're doing. So we'll make this equal to P, the perpendicular, and we'll make it dashed, and we'll go and we'll get A and we'll call it Q because it's our point on our line, and we want it to be yellow and thick. Okay, so what are we looking for? We said we're looking for a point on this line so that the distance from F to that point and that point to Q down here, let's make Q show up, is the same. Well, they're not quite the same here, right? Let's see if we can move it around to make these two the same. So let's move it down a little bit. There it is. So this is the point we want, but we can't just make every point, draw it, and check it over here. That's kind of a bore and doesn't work very well. But what does this look like? If we look a little bit, tilt our head to the right, we can see that we have a side here and a side here that are the same, so that if we draw this here, we have an isosceles triangle. And we can find this angle, and we'll just make that angle the same one. So how do we do that? Let's erase this point. And now we want to find a way to get it. So the first thing we do is draw an arbitrary point on our perpendicular. Let's label it P for point on the perpendicular. And we make this angle here, so we click on our angle maker, P, Q, F. And we're not interested in the value, so we'll go to properties and we'll change it to be just the name, and so that we can actually see it, we'll make it up to 60 here. And we see that that's alpha. And now we're interested in making that same angle coming off this way. Now we need an angle with a given size. The given size is going to be alpha. The bottom right hand, the vertex, erase the 45 that we don't need, click on alpha, apply. And there's our angle that's the same. Let's make it look nice. Up to 60. Put the name in there and not the value. Okay, and now we need a ray so we can see what we got there. F and that point. That's the point we want. And even if we move Q, it will move too. So we need that intersection point right there. That intersection point, we're going to label it CQ because it depends on Q. CQ. That means C sub Q.
with that underline there. Okay, CQ, and we're gonna make it purple and big. Purple and big. Now what we really want is all the points like that for all the points Q along here. That's what's called a locus. We go and we pick up our locus tool, which is over here. We want all the points like CQ that come from Q. There's our parabola. Notice that it went right through our vertex, and it is the vertex of that parabola, and right through our point. Let's right click on that.
Make it thicker and purple.
Now, supposedly, as we move Q, CQ should trace the parabola. Let's see. One move. There it goes. Makes weird angles on that side, but makes nice angles on this side. So that's how to make a parabola. Now, what parabola is this?
Well, that's what we're going to find out in our next mathcast. In fact, we shall see that that parabola is a quadratic function, and that all quadratic functions really are parabolas.